This video is for calculus in the third quarter, reviewing for quiz 8, mostly on optimization and a little bit of differential equations. Okay, so the first part is non-calculator, and let's get started. It says a supermarket employee wants to construct an open top box from a 14 by 30 piece of cardboard. So let's draw that. Okay, so essentially, put the plus sign. Okay, and there are these pieces that are cut out as scrap. Okay, it started off 14 by 30. So let's go with 14 here. Let's go with 30 here. Okay, so the X is going to be the size of the cutout. And that means that this length right here, which will be the actual base of the box, okay, that is going to be 14 subtract X subtract X. So we have 14 minus 2X. This dimension here is 30 subtract X subtract X. So this is 30 minus 2X. Okay, so the three dimensions are X, 14 minus 2X, and 30 minus 2X. Okay, got it. All right, find a formula for the volume of the box based on X, the side length of the squares cut from the corner. So the volume is going to be length times width times height. In this case, it's X times 14 minus 2X times 30 minus 2X. There we go. Okay, find a formula for the surface area of the box based on X. Okay, so the surface area, X, well, there's the base. The base is 14 minus 2X times 30 minus 2X. And then there are the four sides. Okay, so there's this side, this side, this side, and this side. Okay, so this side here is X by 14 minus 2X. Same for this one. Okay, so I have two of those. Okay, so I have X by 14 minus 2X. All right, and then I've got the left and the right, and the dimensions here are X by 30 minus 2X. I have two of those. That's the left and the right. 2X, 30 minus 2X. Got it. Okay, find a formula for the waste from the original piece of cardboard based on X. Okay, so let's call that W of X. And essentially, the waste is going to be X times 4, because there's 4 different sides. There we go. Okay, so that part is really on building equations. A rectangle has a perimeter of 10. Okay, maximize the area. A rectangle that has an area that's maximized turns it into a square, so it's probably going to be a 2.5 by 2.5 square. Okay, so I already kind of know what the answer is going to be. Let's actually do some math and back it up. All right, so if I have a rectangle with a perimeter of 10, let's draw it. Okay, X, Y. Okay, X is the width, Y is the length, and the area we're going to find. Okay, so the perimeter equals 2X plus 2Y. We know that the perimeter is 10. I'm going to divide everything by 2 and move X over. Okay, now the area of that is X times Y, and we're going to replace Y with 5 minus X. Okay, so technically we're X times Y. Y has been substituted with this version right here. Okay, so let's just clean that up. We have 5x minus x squared. The derivative of that is equal to 5 minus 2x. The critical point then is x equals 2.5. Okay, now we have to verify that this is a maximum. Okay, so one easy way to do it is with the number line. If I put 2.5 here, let's put 1 there, let's put 3 there, and I have a prime and a. Okay, the thing I'm trying to do here is maximize a, and I'm using a prime to interpret it. Okay, so if I take 1 and plug it into a prime, 5 minus 2 times 1 is positive, so we are increasing. 3 goes in and creates 5 minus 6, which is negative, so we are decreasing, and therefore we have a max. Okay, so to go from increasing to decreasing is a max. So x value is 2.5. using our formula here, y is equal to 5 minus 2.5, so y is also 2.5. The area is 2.5 times 2.5, which is 6.25. All right, got it. Okay, if y minus 2x equals 6, then find the maximum value for x squared minus y squared. All right, so let's solve this for y. Y equals 6 plus 2x. Okay, now let's actually plug this in. We're actually trying to maximize x squared minus y squared. And if I plug in for my y value, it's going to be minus 6 plus 2x squared. Okay, and I need to do a derivative from here. I could clean this up and then find a derivative, or I could just use the product rule to find the derivative. Either way, I'm going to go ahead and just clean it up now so that I can just use the power rule. So if I have x squared, subtract 6 plus 2x, I'm 6 times 2x, okay? I'm foiling that out, writing it twice and foiling. I'll have minus 36, I'll have minus 24x, and minus 4x squared. Okay, so the 2x times 6 would be 12, and there's two of those making 24. We're subtracting all of those values, which is why they're all minuses. Okay, and that cleans up to f of x equals negative 3x squared minus 36 minus 24x. Okay, it's not in descending order, but it'll be fine. Okay, so I'm going to find a derivative of this. The derivative of this is going to be f prime of x equals negative 6x minus 24. Set that equal to 0 to locate my critical points. And you're going to find that x equals, let's see, add that across negative 4. Okay, so x equals negative 4. All right, so I have my x value. Okay, let's verify that that is an actual maximum. So before I actually get too ahead of myself. And here we go, negative 4 is here. Let's try negative 5, negative 3. We're using f prime to interpret f. Okay, I'll put x on there just for fun. Okay, negative 5 into the derivative creates a positive 30. Subtract this, which is positive, so we're increasing. Negative 3 goes in and creates a positive 18 minus 24. That's negative, so we are decreasing. So therefore, we have a max. Okay, so I verified that. All right, now to find the y value, I take my negative 4, plug it in here. 6 minus 4 times 2 times negative 4, that's negative 8 plus 6, which is negative 2. And our value that we actually maximized, our x squared minus y squared, let's do that. Okay, so I have negative 4 squared minus negative 2 squared. That is 16 minus 4, 12. Got it. Okay, if y equals x minus 1, then minimize the function g of x equals xy plus 5x. Okay, so let's substitute. And I have x. The y value is x minus 1 plus 5x. Okay, I'm going to clean that up. So that is x squared minus x plus 5x. And again, clean that up. That is x squared plus 4x. Okay, the derivative of that then is 2x plus 4. The critical point then is 0 equals 2x plus 4, which means x equals negative 2. Verify that negative 2 is a maximum or minimum. Okay, we're looking for a minimum. All right, so let's try negative 3 and negative 1. Okay, so negative 3 going into the derivative creates a negative. Okay, let's label g prime and g. I'll put x's on there. And negative means it's decreasing. Negative 1 goes in and creates a positive 2, which is increasing. So to go from decreasing to increasing reflects a min. All right, so I have a min at negative 2. Got it. Okay, the y value is negative 2 minus 1. That's negative 3. The value then is going to be, let's see, x times y plus 5 times x. Okay, that is 6 minus 10, negative 4. Got it. Okay. All right, next, use differential equations, which means we're going to use a tangent line, to find approximate values of f of 3.01 given that f of 3 equals -1 and f prime of 3 equals 3. So make the tangent line at 3. Okay, y minus y. Again, here's my y value, -1. And then I have my slope, so f prime of 3, which is the derivative, tells me my slope is 2. And I have x minus the x value of 3. Okay, so I did that. Step 1, make the tangent line at 3. Then you use it on 3.01. Okay, that is an input, that is an x value. Okay, so if I do that, I'm going to see y plus 1 equals 2. Okay, now I have 3.01 minus 3. Okay, and I'm kind of running out of room a little bit here. So let's just keep it going sideways. Y plus 1 equals, let's see, 3.01 minus 3 is 0.01. 0.01 times 2 is 0.02. And then if I subtract 1 over there, I end up at y equals -0.98. Okay? All right, let's do it again. Use differential equations to find the approximate value of g of 1.9, given that g of 2 equals 6 and g prime of 2 equals -4. We're going to make the tangent line at 2. Okay, so we know all the information about 2, we're going to use it. All right, and then we're going to do our approximate of 1.9 on that tangent. Okay, so we go y minus the y, which is 6. The slope is -4. Okay, and then the x was 2. And then I use it on x equals 1.9. Okay, all right, so I have y minus 6 equals -4 parentheses 1.9 minus 2. Okay, so here I have -0.1 multiplied by 4, so that's -0.4. I add 6 over, okay, adding 6 to -0.4 will give a positive 5.6, and there is our approximate. Okay, non-calculator side is done. Okay, now we move to the calculator section. All right, which point on the graph of y equals radical x is closest to the point 7, 0? All right, so basically our graph looks like this. There's that. 7, 0 is right here, and we have points along this curve, and we need to consider the distance between there. Okay? All right, so the ordered pair for this point is 7, 0. The ordered pair for this point is x, radical x. So again, x is the input, the radical x is the output. All right, and we don't want to write it as y, we want to write it as radical x. Okay, so what we're going to do now is the distance formula between these two things. Okay, so the thing we're actually trying to maximize or minimize is going to be f of x equals square root. Okay, and we take the x values, subtract them. So let's just do x minus 7 squared plus, and then we have the y values, radical x minus 0 squared. Okay, and that's our distance formula. It's the distance between the x's squared plus the distance between the y's squared and square root the whole thing. So it's essentially Pythagorean theorem. So that right there is the formula. Okay, so there's our optimized formula. Let's see what we have when we actually graph it. Okay, so radical parentheses x minus 7 squared, okay, plus parentheses square root of x, go outside of it, minus 0, which doesn't really do anything, quantity squared. All right, so all of that should be inside of the square root. All right, so let's just see what that looks like. Just make sure we did it right. Just got that, and minus 0 squared. Okay, got it. Now, if I zoom 6, okay, there we can see the, see if I can get a better view of it. Okay, what we're seeing right here is the min. There's a minimum value on this point. Okay, so what I'm going to do now, see if I can get a little better. There we go. Okay, I need to find that minimum value. So second, calculate, all right, minimum, and there's our first point, surrounded over here, enter, enter. Okay, so we have 6.5 and 2.598. Okay, so my x value was 6.5. Okay, the minimum distance between there is 2.598. Okay, so how do I find the y value? Well, y is defined as the square root of x. So if I just do the square root of x, it's going to be 2.549. Okay, all right, there we go. All right, the next thing, two vertical poles on 16 feet high and the other is 24 feet high, stand 30 feet apart on a flat field. All right, so here we go. So we have a pole here, a pole there. This one is 16, this one is 24. They are 30 apart. There's a value here that is x from there, and that makes this distance 30 minus x. Okay, what we're going to do is a worker wants to support both poles by running a rope from the ground to the top of each post. If the worker wants to stake both ropes in the ground at the same point, where should the stake be placed to use the least amount of rope? All right, so essentially, there's your support line to that pole. There's your support line to the top of that pole, giving you two right triangles. The distance of the rope here is A. The distance of the rope here is B. I'm just going to use this as a little bit of middle ground. Okay, now I have, let's call it g of x is a plus b, and I need a and b in terms of x. Okay, so I'm going to do Pythagorean theorem on this triangle. That would be x squared plus 16 squared equals a squared. So a equals the square root of x squared plus 16 squared. Let's put that in up here. G of x equals the square root of x squared plus 16 squared. Okay, plus square root. Well, I'm getting ahead of myself. Let me show you why there's a square root. The second one, b, I'm going to run Pythagorean theorem on that part. Okay, so when I do that, I'm going to end up with 24 squared plus quantity 30 minus x squared equals b squared. So b equals the square root of 24 squared plus 30 minus x quantity squared. Okay, now I'm going to put that back here. So I have this parenthesis, 24 squared plus parenthesis 30 minus x quantity squared. All right, so let's graph it again. So I'm going to go back to my calculator. I'm going to enter in all of that mess right there. See if I can get the best view possible on that calculator. Okay, pretty good. All right, so square root x squared plus 16 squared. Okay, right arrow to get out of the radical, plus square root 24 squared plus parenthesis 30 minus x quantity squared. Get out of the radical and come down. All right, now let's try zoom 6 and see if we actually can see something. I cannot see something, so I'm just going to zoom out. All right, still not seeing anything. See how far up there. Oh, it looks like I'm just off. Zoom out one more time. So zoom, out, enter. Not bad. Okay, so there I can actually see a picture of it. Again, I'm going to find the minimum. Enter. Enter, enter. Okay, so we have 12 for our x and 50 for our output, which is the length of the rope. So the distance from the 16-foot pole is 12. The length of the entire rope is 50. And the distance to the y pole is going to be 30 minus x. Okay, so 30 minus 12 is 18. All right, now we're back to differential equations. Okay, so use the tangent line at x equals -1. So we're going to set up the tangent line at x equals -1 to approximate g of -1.1 along g of x equals x to the third plus x squared minus 2x. All right, so this is a calculator section. So just go back and type in your function x to the third plus x squared minus 2x. All right, so I typed in the original function. See if I can get that a little better. Okay, there we go. All right, and let's just go back to Zoom 6 because they said to focus on -1. All right, and -1 is not going to be real bad. All right, so trace -1, enter. So essentially, g of -1 equals 2. All right, so I've got the y value I need for the tangent line. Now I need the slope. I need g prime of -1. So just run it. Second, calculate dy dx, -1, enter. And that's going to essentially be -1. Okay, so now that I've got this information, I set up my tangent line. Y minus y. The output of g is 2. That is the y value. Now I need the slope. That's the output of the derivative, -1. Now I have x minus my x value, which is -1. Now I'm going to use it for the value -1.1. Okay, so I'm going to plug that in. So y minus 2 equals -1, -1.1 plus 1. Okay, y minus 2 equals -1. All right, and essentially I have -1.1 plus 1, which is -0.1. Multiplying that by -1 is going to give positive 0.1. So I'm now at y minus 2 equals positive 0.1. Add 2 to that, okay, and I'm going to have 2.1. So there is my answer. So my approximate output on G, okay, at 1.1 or -1.1 is 2.1. And that's not far off from where we were here. Here we were at 2, here we're at 2.1. Okay, use the tangent line at x equals 2. All right, so we're going to set up a tangent line at x equals 2 to approximate the value x equals 2.04 along the curve of f of x equals x squared minus 4x. Go back. Okay, so I've got x squared. Get that better where we can see it. Come on. There we go. Okay, x squared minus 4x. All right, so I've got that. And I'm now going to graph on Zoom 6. And the value that they told me to focus on was 2. Okay, so trace to enter. F of 2 is -4. Now I need f prime of 2. Okay, so second, calculate dy dx, regular 2, enter, and that is 0. Okay, so it looks like that is the minimum. All right, let's use it now. Our tangent line would be y minus y, which is -4, equals our slope, x minus 2. Okay, this 0 cancels all that out. Okay, so it doesn't matter that we're plugging 2.04. It's basically going to be 0, 2.04 minus 2. Whatever this comes out to is still multiplied by 0. So we have y plus 4 equals that. So therefore, our estimate is y equals -4. There we go. Y equals -4. Okay, all right, the challenge ones. Heads up on the challenge ones. There will be 2 challenge ones on the quiz that you can choose to do or not do. You can pick one of them to do for extra credit. All right, so these are going to get a little bit crazy. So I'm just giving you a heads up and just telling you that it's not a big deal if you choose not to do these. Okay, so you choose if you want to watch these parts of the video, or you could watch some and say yes or no as I'm working through. All right, the dimensions of the rectangle of largest area that can be inscribed in an equilateral triangle of side length 4. Okay, so we need a decent picture. All right, so I need a triangle that is equilateral. So what we know is all sides are the same and every angle is 60. Okay, the next thing we're going to have is a rectangle. Okay, one of the sides of the rectangle lies on the base of the triangle, so that essentially it comes up this way. Okay, and I need a dimension. Okay, so if I call this x right there, then this is x over there. Right now I'm at y, and I don't want y. Okay, I want to know exactly how I can get to y without knowing, or in terms of x. That's what I want to do. So here's what I know right now. I know that this entire distance is 4 because they said that the equilateral triangle had side length of 4. Okay, I know the entire thing is 4. All right, now let's go this way. I need to get to y in terms of x. Now, if I drew a triangle this way, okay, I also know that this is going to be an equilateral triangle up here because this bottom is parallel. I know that this is 30 and this is 30. Okay, those are 90s all inside of there. So right now, I know that it's a combination of 30, 60, 90 here, 30, 60, 90 here, 60, 60, 60 there, and all 90s on the inside here. Okay, so let's look at that shape right here. Okay, if I know that this is a 30, 60, 90 triangle, and I know that x is the side length there, okay, that is the side across from 60. Okay, which in a 30, 60, 90 is the middle side of that. Okay, so what we typically do is we start at the short side and we take that, we multiply it by 2 to go to hypotenuse, we multiply from here by radical 3 to go to the middle side. Now to come from the middle side to this side, I have to divide by radical 3. To go from here, okay, over to this spot right here, I'm going to have to actually take this and double it. So that would be 2x divided by radical 3. All right, so what I know right now is that this piece right here, okay, is x radical 3. Okay, this side over here is x radical 3 divided by, okay? All right, so that's what I know. Now, these three sides have to add to 4, okay? So what I know is that y plus x radical 3 plus x radical 3 equals 4. Therefore, I can solve for y, okay? In terms of x, I can say that y equals 4 subtract 2x radical 3. These are like terms. They add to 2x over radical 3. You subtract them to the other side and you are here. So what good does this do me? Well, the thing I'm actually trying to maximize or minimize is the area of the rectangle. So I have a of x equals, and the area of that rectangle is x multiplied by y. So x, y. Now we will substitute. We'll get rid of the y, put 4 minus 2 over radical 3x. We use our calculators to go from here. So I have x parentheses 4 minus 2x divided by square root 3. Outside close. All right, there we go. Now, let's do a zoom 6 and hope that we see a decent graph that has a maximum. There we go. Okay, so I know that I've got that. Let's find that maximum. All right, so my x value is 1.732. My y value, which is the actual area, is 3.464. Okay, so the length, let's call that the x value, 1.732. The area was 3.464. Okay, and if I exit out of that and I perform this operation right here, okay, 4 minus, can't hardly see that, okay, sorry, it's 4 minus 2x divided by square root of 3. I'm going to find that it is 2. Okay, so my actual value is 2. So it said 4 minus 2x radical 3, and that is 2. There we go. So the y value came out to 2. So it should be 2, 1, 1. Okay, and then we have all the other sides and so on. All right, excellent. All right, next one. Boat A leaves a dock at 2 p.m. Okay, and travels due south at a speed of 20 miles per hour. Boat B has been heading due east at 15 miles per hour and reaches the same dock at 3 p.m. At what time were the two boats closest together? Okay, so at 2 p.m. we have boat A here, okay, and it takes off this way. All right, at 2 p.m., okay, so at 2 p.m., okay, boat A is doing this. This is boat A's path. All right, now, boat B at that time is heading this way. At 15 miles per hour, it's heading this way. Okay, boat B is doing this. And at 2 p.m., it is currently 15 miles away. How do I know that? Okay, well, it got there at 3, so 1 hour of travel at 15 miles per hour. Means that it's at 2 p.m., which is an hour early, it is 15 units away. Okay, so if you think about it, you have 15 this way, okay, and you have this point A. All right, now, at what time were the two boats closest together? Okay, asking when they're the closest together is a distance formula again. Okay, so I need to have a formula that describes where A is, okay, and I need to have a formula that describes where B is, okay, and we're going to do it as distance away from this. This is our center, our origin, point 0, okay, so A is traveling at 20 miles per hour. Okay, so if I consider x is the time, okay, x equals hours, okay, then the position of A as it moves along here, okay, that position is going to be, and I don't want to write in this spot, okay, A's position has an x value of 0 and a y value of 20x divided by 60. Okay, so if I take x in terms of hours, all right, then I have to divide by 60 in order, no I don't. Yeah, okay, sorry, get rid of the divide by 60. I'm not going to divide by 60. So again, thinking it through, if I have 1 hour, 20 miles per hour, multiplying gives me 20 miles. That's what I want. I do not have to divide by 60. Okay, B's position, bump that up a little bit. B's position, now it's traveling along this axis, okay, so its x value is going to be a formula, and right now it is currently 15 away, and we are taking away from that at 15x, okay, comma 0. Why is that? Okay, so again, at 2 p.m., which we're considering hour 0, we are traveling closer to the dock. We are currently 15 and it is a shrinking distance, and it's shrinking at a rate of 15 miles per hour. Okay, so I'm taking away from 15 at 15x. Okay, now I'm going to perform a distance formula on these right here. So my function, okay, let's just call d of x, it's going to be a distance formula. And what I do is I take the x values and subtract them. So I'm going to use this one minus this one, so because this one's kind of complicated. So 15 minus 15x minus 0 squared plus quantity. The y values are going to be 0 minus 20x quantity squared. Okay, so this should have a minimum. All right, so what we're actually finding, all right, is as the boats are traveling along here, it starts off with 15 as its distance, okay, and then when this one's here, it goes to there, this one's here, it goes to there, and so on. We have these different distances as B's going this way, A's going this way, okay? All right, so plug it in. Let's hope that it gives us the right answer. So take that away, go back here. Okay, so I have y1 equals the square root, parentheses, 15 minus 15x minus 0 for fun, quantity squared, plus parentheses 0 minus 20x quantity squared. All right, so I have all of that in there. All right, a zoom 6, I'm just going to graph it. I don't know if I'll be able to see anything just yet. Not yet. Okay, let's zoom out. All right, and everything's all scrunched in towards the x-axis, so I'm not really seeing a good graph. So I'm seeing too much x and just enough y. All right, so if I go from negative 8 to 8, I'm just guessing, trying to get a decent graph. That's pretty good. Okay, so I can find a minimum now. All right, in order to find a minimum, a second, calculate, minimum, make sure I surround the min, and answer. So I have 3.6 and 12. So the x value is the hours, okay? Actually, 0.36, okay? Duh. 0.36 hours. The distance away at that time is 12. Okay, let's see, where's boat A at that time? Where's boat B at that time? Boat A's position is described as 0, parentheses, 20 times 0.36. Let's do that. Okay, so 20x. 20x is 7.2. Okay, let's do 15 minus 15x. Again, I can use x because it was the last x value stored from the graph. Okay, so I went directly from the minimum and I went back to the home screen, and it's using 0.36 every time and using it correctly. So I'm at 9.6. Okay, so this one is at 9.6 comma 0. There we go. Got it.